Hey, in this video, we're going to make this very cool wave box. It's an SVG with a little bit of Math.sin in there to make a very cool sine wave. So we're going to code it together, and I hope that you'll learn something, take something away, and with that said, let's jump into the code. So I'm going to start out with just a very basic file here. I'm going to use React, but it's not really about the React code, it's really about our SVG code, and just how we can build this component, which is really just a for fun component, how we can build it using clean code principles and just kind of the math behind it. Really, this is just for fun today. So, as I mentioned, we're starting out with this very simple SVG, little div holding a title above it. For now, we're going to leave a fixed width and height, but we'll actually come in later and make that dynamic. So we know that we're going to need a path element in this SVG. We're going to need to do quite a few calculations to figure out the top, right, bottom, and left. And the calculations for each side are related, but they're by no means identical. And we'll set some constants to have some nice clean code, and we'll just build it a piece at a time. So the first thing that we need is we're going to need some kind of path element in here. So I'm going to go up here and we'll create that. So like I said, I'm using React, but it's really not about the React code today. I like React because it's pretty readable, I feel, for anyone, even if they're not that experienced with React. And this use memo is just going to make a little memoized constant that is basically just a regular constant for our intents and purposes today, because we're not really doing anything with observing. But what it would do is it would create a fresh constant for you anytime that any observables change. So we're going to give it an ID of wave here. We may change that later, but for now, let's do that. Give it a nice teal color. Always make sure to use single quotes instead of double. I made this originally in Code Sandbox when I was playing around, and they convert to double quotes for whatever reason. You know, I'm just going to leave this as strings for now. So what we've done so far is we've just set up a basic path, but a critical piece of a path is that it's filled with points. And the D attribute is what designates those points. So what we need, of course, then, some kind of constant. That's going to hold those points. So we'll have that constant up here. Make sure that we are observing that constant down here, because that's part of what use memo needs. And with that, make sure it compiles. Won't really have anything to see yet over here, and that's fine. But we've got a basic path here. what the next step is. Make sure that we're actually including it down there in our SVG. So now we have an empty path. And if we wanted to, we could go up and inspect that, make sure that our path is appearing in the DOM properly, even if it's not visible to us. So we see that. So that looks good. All right, so the next step is we've got our basic elements in place. That's the easy part, of course. Now we actually gotta do all the calculations and so on. So like I mentioned, one of my goals with this video is to highlight some clean coding principles. Sometimes that means we use maybe a few more constants than, or a few more variables that have really clear names than might otherwise be natural for us. So what I mean by that is that there's some pretty significant math involved in this, and we'll go ahead and just store some constant values that if you were just coding it for yourself, you might not necessarily do that. But if you're coding it and other people might come behind you and be looking at your code later, then you want it to be really clear for them. You want them to just be able to read it without really having to think hard about it. So with that said, we're going to jump into making some constants for our calculations. So I sure didn't remember before just deciding to do this and having to do some research. But when you're looking at a sine wave like this, one complete wave like that is calculated as 2 pi, or since we're using JavaScript here, we're multiplying 2 times Math.PI. If that doesn't make a whole lot of sense, it has to do with calculations of circles, and I'm not really going to get into it more deeply than that, but just know that that piece of the calculation is critical for being able to designate one complete wave in our sine wave. So frequency per side, that's how many total waves we're going to do on each side. And if you're curious, this is a code sandbox that I've created that I'm referencing here just as a completed example. So we have 1, 2, 3 full waves there. So frequency per side 3. Amplitude is the height of our waves above the center, or the depth of our waves below the center. So if our amplitude is 10, that really means the total height of our wave is 20. That's not including the actual line height, or stroke width in the case of a path. So that'll come into play. That stroke width will come into play in a little bit. And we've got our number of sides. So what we need now is just basically a max. We want to figure out how many points we're going to create, or we're going to use for our calculations. And so this is where I said we've got a lot of constants up here that if you're just coding for yourself, you might not necessarily do, because we're really just going to use them all down here. Have really clear code. So we've got a math.floor around this. So what we've got here is that's going to be some kind of max, and I might put it in the console and log it later just so we can see what that number is. But now we've got a total points. It's something like 770 or something like that. That's what this calculation will get us up to, something like that. Anyway, so we'll use that total points all throughout to plug into calculating the each of the 4 sides, and it's kind of a running just total of where we're at as we're creating our wave box. SVG path. We've already created that one, so we don't need that. Anyway, we've got this padding offset. So I mentioned our amplitude is 10. So that means the height of our wave is 10. And I also mentioned that our stroke width is 2px. So really we care about half of that stroke width because half of it goes above the line, so to speak, for the top half of the line and the bottom half of the line. So we've got our amplitude plus that stroke width. That gets us this padding offset of 11. Like I mentioned, we've got our SVG path D. And now we're going to make a path function here. And I'm not great at coding and talking at the same time, so I'm going to type it out. And then I'll talk about it. And of course we see a familiar constant there in that amplitude. So what is our path function? Our path function is simply what is making the wave. So our total points is needed, basically 1/4 of this total points is the points along one side. This path function will take an input of those points, but one at a time, to either create our wave if our wave is on the y-axis, or our wave if our wave is on the x-axis. Doesn't really matter, we're just going to feed it in a point, and it'll return a very nice wave for us. So we've got the constants that we need. So we need to use them somehow, of course. So what we're going to do next, other than check and make sure everything's good, looks like it compiled fine. Now naturally we don't really have anything to see yet, because we haven't added anything to this path down here. But let's go ahead and actually do our calculations for the top, bottom, and sides. We will create the calculations, but not actually plug them in right away. We'll get to that after we create the calculations. So I like to use very clear names. We've got this use callback. Callback's very similar to memo. It actually ultimately creates a memoized object, but it's if you need a function instead of just a constant. So we're going to pass in a point. And I'll explain this here in a minute. So what we're doing right here is like I mentioned, we're passing in a point. We're going to use that point. We're going to use our constants and our path function calculation from above. And we're going to say, okay, for the top, what x values do we need to generate? And the x for the top is pretty simple because essentially the x is linear. It's the y value that's fluctuating up and down to give us that nice sine wave. And we're going to return, ultimately, a string here. So we're calculating our top. Ultimately, what we're going to do is we're going to feed in 1/4 of our points to this calculate top to generate our x values and our curving y values. And then we're going to return those values. Ultimately, they'll be returned and added to this SVG path D, which you can see where we're going with this then. That's used for drawing our line within our path. So we've got our top, we'll move on to the right side. But I will say that the top is actually the simplest of the four sides to calculate. Like I mentioned, the x is linear. The y is, it's not really changing very much. We start out with our padding offset to give it some room to draw the curve, and then we're subtracting the path function. What that means is we're just generating points that are going up and down, but over the long run, they're not really changing. They're not having like a downward trend or an upward trend. It's just a neutral trend, so to speak. Now we'll do a calculate right. Same idea, ultimately. Just the math that changes. And I'll explain here in a minute. It's always good to use parentheses. Some IDEs and Code Sandbox do. Sometimes they strip those parentheses, and so if I leave them off anywhere, I apologize for that, but it's just because, like I said, the IDEs strip them sometimes. So let me do another return. Our return is the same as it was above. And before I forget on this use callback above and here as well, I better put in the observables that we have, which is just that padding offset and that path function. Like I said, this kind of something React specific. Copy those ones from above, but here we also have total points. Looks like we're good to go here. So what's the math right here? Once again, we have our padding offsets. But then on the x, so this time it's the x. You see we have the path function here. This time our x value is ultimately a neutral trend. And our x value is the one that's waving. So it's going back and forth, greater x values and lesser x values. Our y value ultimately is changing. It's actually trending up in terms of our point value. However, in an SVG, the greater the y value is, the actual more downwards, the lower on the screen your line is going to be, or your points are going to be. So what we've got is we're feeding in points. So let's say it's 200, 201, 202, etc. We're taking the total points. We're getting 1/4 of them. So let's say there's 800 total points. It's something like that. Let's say there's 800. This would give us a value of 200 right here. And we're saying like 201 minus 200. That gives us 1. So we have padding offset plus 1. Then 202 minus 200. That gives us a value of 2. You can see how that creates a trend down. A trend of increasing values, which ultimately is making your y decrease. Your line go lower on the viewable screen. Time to do our calculate bottom. This time, so that I don't forget our observables, etc., I'm going to copy paste that, but I'll change the math naturally. Let's just go ahead and wipe out that math. Your x value, padding offset plus total points times 0.25 minus point minus total points over 2. y value, padding offset, it's always good to put zeros in front of your decimals. Some linters prefer that. All right, we're doing the bottom here. So it's the y that has a neutral trend, but it's waving up and down. The x, you actually need a negative trend this time, because think about the bottom. We started at the top left corner of our box, did the top towards the right, did the right side, so we went down on the right side. Now we're at the bottom. We're going from the bottom right corner to the bottom left corner. And just to clarify, I may have said top right corner, but we started at the top left corner of our top. So top left to top right to bottom right. Now we're on bottom right to bottom left. So with that said, once again, our y is neutral, our x is having a trend of decreasing. And now let's do it left. Wipe these out. Give me a moment and I will explain why we're doing a negative value here. Make sure we wrap those in parentheses. Okay. So really, the reason that I did a negative x value here, you can see our x has a neutral trend. It's got the wave, but it's a neutral trend on our x. And it just looked nicer, actually. You can see the pattern here with each side. And if this x, if I hadn't put that negative, it would have actually been inverted. So down here in the corner, it would have been bumping right up against the old wave, that wave from the bottom. It just looks better with the negative value there. So all that said, we've got our calculations, but we haven't actually used them yet. So our final step in terms of making the box is to tie it all together. And of course, we can't forget to put that animation in there. So we'll do a callback. And as we create our wave, we're ultimately going to call this function right here. And create our wave will actually populate this SVG path D. With that said, we actually have to give an initial point to our SVG path D. Naturally, we wanted to start basically at 0, 0, except adjusting that for our padding offset. And we have a pretty good size for loop here. So we're going to increment all the way up through our total points. And then it's as simple as we say for the first quarter of our points, we want our SVG path D to be populated with the top. Then we're going to say otherwise. We want it to then take the next quartile, copy paste this. We want to calculate the right side. Calculate our bottom here. So we've got the third quartile. And then the reason I chose else ifs instead of just having if statements is so that at the end, I don't have to write one more calculation or one more parameter range. Now I can just say else SVG path D dot push calculate left. So now, after all that, we should see a little something. We do. That's good. It's looking good so far. It's interesting to note ours is looking a little bit different than the Code Sandbox original that I had. So let's keep going. Maybe we'll figure that out in a minute as to why that is. Let's see. So we've got our starting point. I think something else we need in our create wave. Let's get an ending point. So that'll be after our for loop. What we're doing here is we're just joining back up to the original points. There's no gaps or anything. And the only thing left here is make sure that we've got all of our observables in here. It's kind of a lot on this function. Let's see how that looks. Yeah, we're definitely a little bit off. It's interesting. See if we can figure out. I bet I got a typo somewhere. One of my functions up here. Alright, let's start at the top. looks okay. Padding offset plus point, padding offset minus path function. Oh, I bet it's some wayward parentheses somewhere. I think it's on our calculate left. I think that because look at this image. Everything looks pretty good until that last one. So let's see. Calculate left. We've got our negative path function, point, padding offset. Total points times 0.25 minus point. You know what? Got our padding offset there. I bet that'll fix it. There we go, that looks nice. Alright. Now there's only one thing left to do. We've got our box built, just gotta get our animations in there. So I've included I've included classes, which is a reference to this style sheet here. And this is JSS, if you've not seen it, we'll use that syntax. So instead of an ID of wave, let's say class name equals classes.wave. Then over here we'll say wave. Animation, let's see. We'll create some animation and we'll call it dash. And we're going to say animate forwards. Get a stroke dash array, and I'll explain these in just a moment. Stroke dash offset, 1200. Let me put in our animation, then I'll explain those. Alright, let's see if that works, and then I'll explain. Doesn't like my semicolon in JSS. Here we go. Let's hit that. Looks like something's not quite right. Oh yeah. Depending on whether you're in Code Sandbox or whether you're actually in a more formal React app like this, sometimes you need a $sign in front of that. That looks good. There we go. There we go. Looks like we got the final product there. So this stroke dash array, what that does is that actually breaks up your line in an SVG. In this case, I'm saying make my line 1200 pixels. So then there'd be a line of 1200 pixels and another gap of 1200 pixels and then a line of 1200 pixels. So it's really like whatever your line is, you're saying this much visible, then this much of it invisible, then this much visible, and so on. Just a repeating pattern like that, at least with how I have stroke dash array here. Stroke dash offset it's an offset, like my padding offset was before. It's a shift. In this case, I'm saying shift that dash, that 1200 unit dash, shift it to the left by 1200 pixels. So then if I didn't have this animation, see what happens when I take that out. I would just have nothing here because I've shifted my dash 1200 to the left, so it's not visible anymore. So this animation comes in and says, okay, we started at 1200 shift to the left. Now let's actually unwind that down to 0. So instead of 1200 to the left, over the course of 3 seconds, I'm shifting it from 1200 to the left down to 0 to the left, or basically being unshifted. So that's all there is to it. One more thing. Let's go ahead and make our width and height dynamic here. what we got here is we're saying, how big does our box need to be? So this is for the SVG container. Contains our path. It's a square, ultimately, so the width and the height are the same. Check that, make sure it looks good. So I said total points over 4. Each side is 1/4 of the total points. Plus we have our padding offset. Well, for our width, we need to double that offset. Same thing with our height, because each side has some offset from the edge of the SVG container. So our left side, for example, is offset by 11, which is 11 pixels. And our right side is also offset by that 11, so we multiply it by 2. All right, let's make sure we get in the last of our dependencies down here, because I'm seeing that a little compiler warning. So I see we're missing create wave. Class is dot wave. There we go, looking so good. Hope you enjoyed this video, and I'm going to try and put out one more like it per week, see if that happens. And feel free to subscribe if you thought it was useful and would like to continue having tutorials like this one. Thank you.